Jai Hind everyone. I'm Dr. Niti Maheshwari, and today I'm going to deliver a lecture on environment and ecology, and the topic of my today's discussion is natural resources. Now, by saying natural resources, these are those resources which are occurring naturally in the environment, and they exist naturally, and they are undisturbed by humanity in a natural form. So some of them, they are essential for our survival, while many of them we are using to satisfy our requirements or what we want. All we need to see that what natural resources we are using, and we are going to find out ways so that we could limit their usage, that is, we can conserve them for the future generations. Because now the stress has been on the utilization of the natural resources, not only for ourselves, but also for our future generations can also use them, that is in a sustainable manner. Now, coming to the classification of natural resources, if I discuss classification, then the natural resources, they are of two types, renewable and non-renewable natural resources. By saying renewable resources, I mean to say that they can be replenished naturally. Replenished naturally, that means some of the resources like sunlight, like air, like wind, they are continuously available and their quantity is not affected by our consumption. Whereas non-renewable natural resources are those which are either forming slowly and they do not naturally form in the environment. Either their replenishment is occurring in a slow manner or they are not going to be generated again in the environment. So minerals are the most common resource including in this category. Now, here, by the human perspective, the renewable resources, they become non-renewable only when their rate of consumption exceeds the rate of their replenishment. And one of the good examples of this is fossil fuels. We know that we are consuming fossil fuels at a faster rate and they are not being replenished in the same manner as we are consuming them. Now, first natural resource that I'm going to discuss today is water resources. Now, the water resources, here I'm showing in the diagram that out of the total water resources which are present on the earth, 97% of the water resource is the salt water. Whereas the 2% of the water resources, they are present in the form of water which is frozen water in the form of glaciers and ice caps. Whereas 1% of the water is available for the human consumption. Now, if I divide this 1% which is available, out of this 1% which is available for the human consumption, 97% of the earth is the saline water and only 3% fresh water is available. So, this fresh water is the 3% which is fresh water. Most of its water is fixed in the form of ice caps and the glaciers. Whereas groundwater forms 30% of the total fresh water and the other surface water is only 0.9%. And this surface water is in the form of either lakes, which is the majority part, around 87%, and swamps, which are around 11%, and rivers, which forms the 2%. Now, we are using water in a variety of different manners. If I say a variety of different manners, then we are using water for agriculture, then we are using for industrial purposes, household, recreational and environmental activities. So these are the basic reasons for the degradation of water. So first and foremost reason is to meet the need of increasing population. We all know that the population is increasing day by day. And since the population is increasing, the requirement of basic needs or basic facilities is also going to increase. So it is putting a lot of pressure on the environment. Then surface water, which is water from the ponds, lakes or rivers, and groundwater, they are being overdrawn. Obviously, to meet the requirements, we are consuming water at a faster rate. Then, second is the sewage. That is the wastewater from domestic and municipal use makes fresh water unfit. If sewage get mixed with the fresh water, then that water is not fit for the drinking purposes. Next, wastewater from all the industries, it flows down these surface water bodies and groundwater bodies and they get polluted. So the industrial water, the untreated industrial water which is flowing down, it is going to pollute the different rivers, the different lakes. Surface water is getting polluted by the processes. Now, coming to the effect of groundwater usage. The first effect, major effect which is seen is land subsidence. By saying land subsidence, if we are consuming water at a faster rate, the aquifer, it becomes compacted. It is also known as the ground movement. By saying ground movement, I mean to say that the water is being moved out from the earth, groundwater is moving out from the earth, and the sediments, they are getting compacted. As a result, it results in the movement of the land out there. That is known as the land subsidence. Second major effect is lowering of water table. Obviously, the water table, the fresh water which is available underground, it is determines the water table, and since the consumption is taking place at a faster rate, the water table is getting lower day by day. Third major effect is the water logging. Now this water logging, it happens in those areas where water is not able to flow down deeply into the soil. It may be possible that below the layer of the soil, a layer of clay is there and water is not able to seep down deep into the soil. So the water is going to stand on the agricultural area or the other areas, and the plants which are present on that land, they are getting excessive amount of water, and hence they are going to die due to the presence of excessive water. Next is the salt water incursion. This generally happens in the areas along the sea coast. Why? Because the fresh water, it acts, or it is floating like a lens over the salt water, and for every 1 feet of the fresh water which we are drawing from the areas, the level of the salt water increases by 40 feet. And since then the salt water, it start getting mixed with the fresh water. So it flows to the freshwater area, and this is known as the salt water incursion. And last is the pollution. Obviously, as I've said, the sewage, it is the major cause for the pollution of the water bodies. Now, there have been conflicts over water. One of the major conflicts were the Kaveri river water dispute. Now, the sharing of waters of the Kaveri has been the source of serious conflicts between the Indian states of Karnataka and Tamil Nadu. We all know that the state of Karnataka contends that it does not receive its share of water from the river as Tamil Nadu does. So, decades of negotiation between the two parties have borne no fruit. Another one is the Godavari water dispute. Now, the Godavari river basin is spread in the states of Maharashtra, Odisha and Madhya Pradesh. Alright. And Karnataka and Andhra Pradesh. So, these are the two major disputes, water disputes, which have taken place in India. Now, coming to the waterborne and water-induced diseases. Now, since the fresh water is getting mixed with the different pollutants, they may be either from the sewage, from the industrial waste, or from the different parasites which are present, they cause different types of water diseases. Now, water diseases, they can be waterborne. By saying waterborne diseases, I mean to say it is caused by ingesting of water contaminated by either human or animal feces. That is a polluted water. or the urine containing pathogenic bacteria and viruses. And this is responsible for causing cholera, typhoid, amoebic dysentery and other diarrhea. Then, next type is the water wash diseases. Now, this is caused by the poor personal hygiene and it includes scabies, trachoma, flea, lice. They are known as water wash diseases. Next is the water-induced diseases, which are also known as water-based diseases. Now, these water-based diseases, they are caused by parasites found in the intermediate organisms living in water. When a parasite lives a certain age, any age in the water, that and it going to infect the water, and if that water is taken by the human beings, then it is known as water-induced diseases. Water-related diseases, they are transmitted by insect vectors which breed in water, and it includes dengue, filariasis, malaria and different types of fever. Now, there are certain problems like fluoride and arsenic problems which are present in drinking water. Why it is so? These fluoride and arsenic, they are present, or they are the trace elements which are present in the natural, or they are the natural contaminants, and they get leached into the groundwater from rocks and sediments. Now, WHO has given certain guidelines. It says that the permissible limit for arsenic is 10 micrograms per liter and for fluoride is 1.5 milligrams per liter. If the amount of arsenic and fluoride is high in water, then they cause different types of diseases. For example, chronic exposure to arsenic, it is going to lead to discoloration and thickening of the skin and also cause cardiovascular disorders or cancer. Then, excessive fluoride level, they are associated with mottling of the teeth and bone and joint deformities. Excessive fluorosis is the name, and the treatment. Now, this arsenic, it can be removed by generally two steps, oxidation and ion exchange. Whereas fluoride, it can be removed by the filtration process or by precipitation process, and they are known as defluorination. Now, second resource that I am going to talk today is the mineral resource. Now, mineral resources, they occur or they form the intrinsic economic interest on the earth crust in such form, quality and quantity. And there are reasonable prospects of eventual economic extraction. And the mineral resources, they are a type of non-renewable natural resources because they cannot be replenished again and again. And we are extensively using minerals. Minerals are being used for the construction of houses, manufacturing machines, automobiles, on ornaments, in body parts, in various defense equipments. Now, because we are using minerals in a variety of manner, there is overexploitation of mineral resources, and the overexploitation of mineral resources is causing a rapid depletion in high-grade mineral deposits, then wastage of mineral wealth, then pollution of environment from mining. Obviously, we all know that mining, wherever mining is taking place, that land cannot be used further, the water bodies get polluted. Pollution caused by heavy energy requirement of mining industry. Coming to the conservation of minerals, because if we cannot stop the utilization of minerals, at least we can slow down the process of mineral exploitation. So, economy in use of mineral resources, making finished products that last long, not 1 month, 2 months, 6 months old products to be formed, but which can be used for longer period of time. Then we can reuse and recycle metals, use of some cheaper substitutes, more efficient recovery of minerals, materials from minerals, search for new deposits, protection of existing mineral deposits. Here, I have already taken. Now, sorry, the 3 mineral cycle that I am going to take today, the first one is the carbon cycle. Now, we all know that carbon dioxide is present in the atmosphere in high amounts. Though it was smaller, but day by day CO2 is increasing. This CO2 is fixed by green plants by the process of photosynthesis, and it is converted into organic compounds. Now, the plants during daytime, they utilize CO2 to form the organic compound, but during night, their respiration process again gives back CO2 to the environment. Now, the plants which are fixing the CO2, these organic compounds, they are being utilized for feeding the all living organisms, whether animals, whether birds or human beings. And during the process of respiration, we all take in oxygen and give out carbon dioxide. After death, the organic compounds which are present in animals, they get decomposed into carbon compounds, and the decomposers, they break down back into CO2. Similarly, the green plants, after death, they release the dead organic matter, and decomposers like bacteria and fungi, they react upon them and they again give back CO2 into the environment. Now, the carbon which is present in the fossil fuel, we all know that coal is nothing but carbon. Petroleum products, they have huge amount of carbon. So, the carbon which is present in fossil fuels, on combustion, it gives back CO2, and these organic compound green plants, when they die, they get buried in the soil, and due to high temperature and pressure, after many years, after the process of qualification, they lead to the formation of fossil fuel. So, here you can see that mineral cycle is nothing but the movement of minerals between inorganic and organic matter in the environment. The second cycle that I am going to discuss today is the nitrogen cycle. Now, atmospheric nitrogen, it can be fixed in 2 different manners. First, nitrogen fixation is through the nitrogen fixing bacteria, and the second is through the process of lightning. Now, this nitrogen fixing bacteria, it converts the atmospheric nitrogen into ammonia, and the ammonia, by nitrifying bacteria, by the process of nitrification, it gets converted into nitrites, and these nitrites, by further nitrification, by nitrifying bacteria, they get converted into nitrates. Similarly, during the process of lightning, N2 and O2, they both combine to form NO, nitric oxide. And this nitric oxide, it reacts with water to form HNO2. And the HNO2 again reacts with oxygen to form nitric acid. Now, this nitric acid, when it falls down on the earth, these nitrates, they react with calcium to form calcium nitrates. So, these nitrates, they are present in the soil and they are absorbed by the plants. That is assimilation, absorption of nitrogen in plants. Now, since plants are fixing the nitrogen, this nitrogen which plants are fixed, it when consumers, especially the primary consumers or the herbivores, they eat the plants, this nitrogen is being absorbed by the animals. Then after that, the decomposers, they work on the animals and they release the ammonia, and finally ammonia again gets converted into the nitrites by the nitrification process. Now, the nitrites, the denitrifying bacteria acts on the nitrates to release nitrogen back into the environment. Now, this is about the nitrogen cycle. The third cycle is the sulfur cycle. Now, here you can see that the sulfur in atmosphere is present in the form of SO2. it is also present in the form of sulfates in soil and water. Now this atmospheric sulfur dioxide, it forms acid rain. In the presence of hydrogen, in the presence of oxygen, this SO2, it forms sulfuric acid. And when rainfall occurs, this acid comes down to the earth. So this sulfuric acid, it lands into soil and water in the form of sulfates. And sulfur is also present as deposits like iron sulfide, FeS2. So there is a reaction, there is a reversible reaction between sulfates and sulfides. The sulfur which is present in the deposits or in the soil or water, they are coming out from the volcanoes or the power plants. Again, they are going to release the atmospheric sulfur back or in the form of SO2. Similarly, the plants and animals, they take in sulfates in the form of organic sulfur, and by the anaerobic after they die, by the anaerobic respiration, they are decomposed by the bacteria back into hydrogen sulfide. So this is all about the sulfur cycle. Thank you.